Hello there, this is Ms. Nakayama. Today's lesson is 6.3 Medians and Altitudes of Triangles. We are continuing with the vast amount of vocab that's in this chapter and how important it is to keep it all straight. So, to continue with that, the first thing we're going to do is talk about the median of a triangle. Okay, the median of a triangle is a segment that joins the vertex to the midpoint of the opposite side. So this is our median right here. Can't draw very well. But you need to remember, it is a segment that joins midpoint. Vertex to the opposite midpoint. Vertex to the opposite midpoint. Vertex to the opposite midpoint. So, just like we were talking about yesterday, our points of concurrency, if you draw all three medians, as we are in the next box, they meet at a point called the centroid of the triangle. Okay? It is always inside of the triangle. It is, if you think about medians in the center of the road, centroid is where the medians intersect, this point P. Okay? A little bit of trivia about it. It's actually, if you had a triangle, it is the center of gravity of that triangle to get it to balance at that one point. So, then we have an altitude, and again, going along with that, knowing the definition. All right, an altitude is the perpendicular segment that joins a vertex to the line containing the opposite side. So if I have an acute triangle, then my altitude is going to be inside the triangle. Okay, I'm going from the vertex perpendicular to the other side. In an obtuse triangle, I'm going from the vertex to the line containing the opposite side, but I have to be perpendicular, so it can't be inside the triangle. And of course, if it was a right triangle, then that altitude is actually one side of the triangle. So you have different possibilities there. Okay, but you got to remember, it's the perpendicular distance from the vertex to a line containing the opposite side. Now, where do all the altitudes intersect? What is their point of concurrency? It's called the orthocenter. Okay, and if you look at these pictures, if it's an acute triangle, it's inside. If it's a right triangle, it's on it. And if it's an obtuse triangle, it's outside. So, as we said yesterday, you've got to remember what word goes with what segment. So, the little things that we had yesterday, we had peanut butter crackers, and we had ABI, Alabama Bureau of Investigation, or AI, always inside. The median and the centroid, some people like to use something called MECE, median, centroid. Okay, or I just remember the median's in the center of the road, so it kind of goes together. But altitude and orthocenter should be easy for everyone because you have a class every day called AO. So the altitude is called, where the altitudes meet, their point of concurrency is called the orthocenter. Okay, we have a centroid theorem that is very important, and I'm not particularly fond of the way the theorem states, but it works. The medians are concurrent at the centroid, which is 2/3 of the distance from each vertex. So this is the way they state it. If you have a median, let's look at BF is a median, so F is the midpoint. P is that point of concurrency. So that point of concurrency, we know that BP is 2/3 the distance of the whole thing. Okay, but this one to me is a lot easier to know that the longer segment is equal to twice the shorter segment. Okay, you look at this, you can clearly see that one of these is longer than the other. They have a ratio of 2-to-1. This short one is always half of that one, or this long one is always twice the short one. So that's what I'm going to concentrate on. I'm going to concentrate on whether we're given the whole median or part of the median, and you'll see as we go along. Okay, now just to review, all the kinds that we've had are perpendicular bisectors. They intersect at the circumcenter. We had PBC. Angle bisectors, always inside, or ABI, Alabama Bureau of Investigation. Medians intersect at the centroid, that's MECE, and altitudes intersect at the orthocenter, which is AO. So you've got to remember all those. It's going to be a heavy heavy part of the quiz on next week. So you just need to make sure that you know what each of these represents. All right. In an isosceles triangle, all four points are collinear, all 4 points of concurrency. That's these 3 points 4 points we're talking about. So if it's isosceles, they're all collinear. If it's equilateral, they actually are all intersect at the same point. Okay? These, you have this information. I prefer not to memorize that information because I think it's a lot. I think it's easier to draw it and see it. But it is probably good to know that in an acute triangle, all 4 points are always inside the triangle. On the obtuse and the right, some are inside, some are outside. It's a lot. Okay, so let's go do our examples. PQ is the centroid, okay? If it is a centroid, you need to think to yourself, okay, that's where my medians intersect, and they always have a ratio of 2 to 1, okay? 2 to 1 or 2/3 the distance, however you want to do it. But 2 to 1 are the 2 parts, and the whole is 3. So in this particular one, this first part, AQ, that is a part of a median. All right, and so that means I'm going to go label my picture. This is 21. And if that's 21, remember, it's always 2 to 1. So the short piece is 21, then the long piece is going to be twice that, which is 42. So I have to find QL. QL is that longer piece, so that's 42. And then I have to find AL, which is the whole thing. I'm going to add them together, and 42 plus 21 is 63. Okay? Number 2. Look at this picture. JA is 72. JA, every time we know that Q is a centroid, so I know that JA is a median. And this time that median is the whole thing. And if they give me the whole thing, then I'm going to take 72 and I'm going to divide it by 3. And when I divide it by 3, I get 24. That means that the small piece has to be 24 and the longer piece is twice that, which is 48. So now I'm going to go answer my questions. JQ from my picture is 48. QA from my picture is 24. I just think that's a little bit easier than doing the equation with 2/3 of the distance. But if you don't like this, let me know. I'll be happy to show you another way. All right, number 3, QA. Not QA, it says KQ. KQ is 10, and KQ is part of the median. It's not the whole thing. So that means I'm going to go label KQ to be 10. I can tell from my picture it's the longer piece. So the other one is the shorter piece, and it's going to be smaller, so it's half. So it's got to be 5. So QA for my picture is 5. And KA is the whole thing, so I got to add those two together, and that's going to be 15. So I hope you're thinking that's pretty easy because it's not that bad. All right, look at these two. BL is 12. I'm going to assess. BL is the whole thing. And when I'm given the whole thing, I'm going to divide that number by 3. Pooh Bear. I'm going to divide that number by 3. 12 divided by 3 is 4. So then I go label my picture. So BL is 12. That means the smaller piece is 4. And the big piece is twice that, which is 8. So BP, we just found out from our picture, is 8. And PL is 4. So every single one of these, y'all, it is so much easier to do it on the picture and then answer the questions. Hope y'all can see that. All right. Number 5, I have VQ equals 5. That is a part of my median. And if that's the small part, the long part is RQ, and that's going to be twice, so it's 10. So RQ is 10, and RV is the whole thing. I got to add them together. That's going to be 15. All right. You turn to the next page. Point G is the centroid of triangle ABC. AD is 8, AG is 10, BE is 10. Oh, funny, they didn't label that on there. Okay, so AD is 8, AG is 10, BE is 10, AC is 16, and DG is 6. Okay, so back to this. AC is 16. It's a centroid, y'all. And if it's a centroid, then that means these are all medians. And if they're all medians and AC is 16, then I know that each part has to be 8. Okay? And I know the medians are divided in a ratio of 2 to 1. So I'm going to go label this picture from what I just remembered. I know that I have the midpoints. D is a midpoint, so BD has to be 8. E is a midpoint, so EC has to be 10. DG right here is 6, and that's the smaller part. That means that GC has to be 12. And AG is 10. That's the bigger part, so GE is half of that, the smaller part, so it's going to be 5. And I don't know anything about BF, so I don't know either part, so I can't find it. So let's go answer our questions. DB, labeled from my picture, it's 8. EA, from my picture, EA is the whole thing, so I got to add those together and get 15. CG is 12 from my picture. BA is BA. Got to put 16 because I got to add them together. GE is 5 from my picture. CD, I got to add them together. 6 plus 12 is 18. BC, where's BC? BC is adding 10 and 10 together, so that's 20. And AF is half of 16, which is 8. So, again, I hope y'all can see it's so much easier to go and label the picture and remember those relationships and then go answer those questions. Okay, number 14 still deals with the same picture. It says DC is 5x plus 2y. Write an expression to represent DG and GC. So they don't want numbers, they want an expression in terms of this here. So what I'm going to go is think about is that DG is the smaller part and GC is the big part of the median. And remember, the small part, the whole thing, okay, from our centroid theorem, okay, we got 1/3 and 2/3. So the DG, which is the small part, is going to be 1/3 of that expression. GC, which is the big part, is going to be 2/3 of that expression because it's 2/3 of the whole thing. All right, number 15 says find the coordinates of the centroid of triangle ABC with vertices A 0, 4, B -4, -2, and C 7, 1. So hopefully you've already beat me to it, but you should plot that. So I plotted all that on there. I didn't want to distract you. So I've plotted my triangle, and I'm going to tell you there's 2 ways to do this. Easy way, hard way. Your pick. I'm going to tell you the hard way, but I'm going to do it the easy way. So again, if you want to do it the other way, let me know. I'm happy to tell you. So the harder way, the longer way, is that you could find the midpoint of a side. Pick any side, doesn't matter. Find the midpoint of that side, find the distance of that median, and then find the point that's 1/3 of the distance from that midpoint you found in number 1. Or you could just say, I'm going to go average all the coordinates. Well, if I'm averaging 3 numbers, okay, then I'm going to add up 3 numbers. So I'm going to add up my x coordinates, 0, -4, and -2. 7. That's the x coordinate. 0, -4, and 7. My y coordinates are 4, -2, and 1. Okay, y'all, averaging. How do you find the average? You add them all up and you divide by how many you have. So how many did we add up? 3. So I'm going to divide each of those answers by 3. And when I do, I will find out that my centroid is at 1, 1. Because this, of course, is 3/3, and that, of course, is 3/3. So this is a little bit easier, but if you wish to do it that way and want to, you will see you can do it. You get the exact same answer, okay? I can even show you just real quick, but if you were to use side AB, the midpoint of AB is right here. And halfway between that point right here and C is going to be at this point right here. Because this is 1, 2, 3 units away and 1, 2, 3 units away. And my graph might not be correct. So as I was saying, this is the midpoint of AB. So if you find the distance from 7 to -2 is 9, and to go 1/3 of that is 3, so 3 units away is at that 1, 1. That's the other process. But if you don't have the ability to have a horizontal or vertical, it's a little bit more challenging. All right, last problem, 16 here. BD is an altitude. Don't know what happened. Oh, anyway, BD is an altitude of triangle ABC. Find X and segment AC. So X, you don't know anything about the lengths here, so you can't really do anything with these expressions of X. You do know this. You know that 15X has to equal 90. Okay, so I'm going to write 15X equals 90 and divide both sides by 15, and X equals 6. So now to go find AC, I happen to think it's easy to do it algebraically first. So AC is equal to AD plus DC. And AD is equal to 3x plus 8. And DC is equal to 5x minus 6. When you combine those, you get 8x plus 2. And so I'm going to plug in for x equal to 6 and find out that AC is 50. So that is all that we have for medians and altitudes of triangles. Thank you so much for watching. Please do not hesitate to come see me or email me if you have any questions. Y'all have a great day.